What is a programming language? If someone asked you this question, can you answer it? Programming is simply a way for us to give instructions to computers. We give it an instruction manual, and the computer follows. Without code, computer programs wouldn't do anything. You wouldn't be able to move the mouse around on your screen. You wouldn't be able to Google things. You wouldn't be able to play Pokemon on your phone, right? I can't just tell my computer what to do. You see, computers don't understand English or any other human language for that matter. So, what language do computers speak? Well, they speak in ones and zeros. All electronics speak that language of on or off, 0 or 1. But writing ones and zeros would be gibberish for us. It's hard for us to communicate like that, right? So humans have developed programming languages that are in between human language and machine language. That is, zeros and one. Some programming languages are lower level than others. That is, they're closer to machine language. And other programming languages are higher level than others. That is, they're closer to English or a human language. And there are lots of programming languages. You have languages like assembly that is really, really close to machine code. You have languages like Python and JavaScript that are really, really close to English. Okay, that's great. We have these pieces, but what are we missing here? I mean, if I want to find flights to Hawaii, how do we go from here to, well, having, let's say, a website show us a display of all our flights, telling the computer to show those flight information on our screen? What are we missing here? Well, we have these programming languages that we usually write on a file, such as Python, JavaScript, maybe even Java. And then we somehow need to get these files that we write into ones and zero so that our machines can understand. Well, we need a translator, right? We take our code that we write, what we call a source code, written in a programming languages, and we give that to a translator that can understand that language, but also understands machine language. And this translator just translates these files for us. So what is this translator? It's not really a person, right? I'm not giving my code to somebody and somebody's going to just start shouting at the computer. That would be quite silly. What is this translator? Ready to have your mind blown? Well, it's another program written by a human. It can either be an interpreter or a compiler. Now, Python usually uses an interpreter, usually. And an interpreter, just like a translator, goes line by line through our code and executes our code on our machine. Compilers are a little bit different. They take your code all at once, reads the entire file all at once, and then translates that to machine code. So again, interpreter goes line by line, and each line executes an instruction. A compiler takes the entire file and turns it into machine code. Now, the differences between these two are a little complicated and beyond the scope of the course. And don't worry, we're going to come back to this topic. But I want you to just have this general picture that when we write code, whether it's Python, JavaScript, Java, C or C++, what we're doing is we're typing it in a language that is human readable. We're giving it to one of these translators, like an interpreter or a compiler, and these spit out code that are able to run on our machines. So to review, interpreters translate line by line and execute the line before going to the next line. Compilers translate all lines of a program to a file, usually called a binary, and execute the whole file at once. Now, in the next video, we're going to talk about this process a little bit more in detail, especially on how it works with Python. But why did I start with this? I mean, this is a complex topic. Most developers, especially if they're starting out, don't even know of this process. They just know that they write code and then it runs. So why did I teach this here? Because in order for us to be able to write Python code, well, I can't just write it anywhere, right? If you went right now to your computer, and let's say you opened up a text file like this one, and you started typing Python code, but for now we don't know Python. So let's just say I want to go search for Pokemon. Well, this might be code. We don't know if it is, but I can't just use this, right? I mean, this isn't really Python code, but how would my computer know what I'm talking about? In order for us to start writing Python, we need to download this translation service. And in the next video, I'm going to show you how to do that. I'll see you in that one. Bye-bye. Welcome back. We just learned what a programming language is. It's just a set of instructions that we give to a translator. And this translator can be an interpreter or a compiler. And we give these files that we create, our own code, our source code, to these translators. And they allow us to give instructions to machines, to computers, to phones. So we learned that we need these machines in order for us to write Python, right? How can we get these? Well, we download them. And here we download Python from the Python Software Foundation, from python.org. Now, before we download Python, we're going to wait a little bit. Because in this course, I want you to understand why we're doing things. Not just follow my tutorials, follow my videos, and, well, not understand the meaning and the fundamentals behind why we're doing things. You should be able to teach what you're going to learn. So let's take a pause here for a second. If this is the first time that you're learning a programming language, I have some good news for you. At the end of the day, all programming languages do the same thing. They tell the machine what to do. However, different languages have different ways of doing it. The beauty is that most languages have very similar principles. If this is your first programming language, well, this is going to be the hardest part, learning the first one. Afterwards, every new language you learn becomes easier and easier, in the sense that it's not the same as, let's say, learning English and Japanese, two very distinct languages. In programming, things become a lot easier as you learn that first foundational language. Now, if this is not your first language, and let's say you've written code in C, C++, or JavaScript, and you just want to learn Python, well, you're going to find these first couple of videos quite easy. But bear with me. Trust me. We're going to get into some advanced topics here. And we're going to make you a full-fledged developer by the end of this. But let's go back to this topic at hand, this idea of downloading this translator. The thing is, when people refer to Python, the language, they're most likely talking about the implementation. That is, they're talking not about the language itself, because Python, the language, is just a specification. You can think of it as a document that somebody wrote that says, hey, when I write the words DEF, that means something in Python. And when I write something like print, that means something in Python. But the translation machines, well, we can have tons of them, different interpreters, different compilers. For example, python.org, when you click download here, you're actually downloading this, the C Python, because it's written in the C programming language. This is what you're downloading. It's a program written in C to read your Python file and, well, run it on a machine. but there's other implementations. For example, there's the Jython project. And this is a translator that is written in the Java language. There's PyPy, which is actually written in Python. So it's a interpreter, it's a translation machine written in Python. And then there's also things like Iron Python, which is written for the .NET framework. So here's a little trick question. When you download from Python, the official language is actually CPython. You're downloading this interpreter that follows the Python specification. But at the end of the day, it's a machine built by somebody. But these machines can, come in many forms. So when most people talk about Python, they're talking about this one, CPython, that, does our translation for us. It interprets our Python code and runs it on a machine. So we're downloading this. And if you want to really get into details as to what we're downloading, we're downloading a machine that takes our Python code, which, don't worry, we're going to write, and it goes through the interpreter, which we download using CPython. And this CPython is going to create something called a bytecode. For example, this bytecode prints hello world on our screen. Now, this might look like gibberish to you. And even for me, I don't know bytecode. This looks pretty, confusing, just for printing hello world to the screen. Well, the interpreter does that automatically for us. We don't see it. It's behind the scene. Now, once it creates a bytecode that is closer to machine code, it then uses the CPython virtual machine. Again, just something that runs this code, and then this code gets run on our machine. Now, you're never ever going to be asked this question in an interview. I mean, maybe. And most developers don't know this. But I want you to use this as a reference. That when we write Python code throughout the rest of this course, this is what's happening. We're writing Python. It gets interpreted line by line and formed into what we call bytecode. And this bytecode gets run on the CPython virtual machine, which runs on our computers, our phones, our laptops. And when we're downloading from python.org, we're downloading these two pieces so that once we have them downloaded, we can run Python. All right, that was a tough one. And I mean, we just got started. I hope your brain isn't exploding. Again, this is something for you to use as a reference. But you know what? I think it's time for us to learn how to actually run Python code. And don't worry, we are getting there. We are going to write our first Python program very soon. I'll see you in the next one. Bye-bye. All right. Oh, man, we've been talking for a long time. How can we finally run Python code? I want to start coding, right? Let's download this translation service, right? Well, I'm sorry. Actually, this is something we're going to do later on in the course. And I know what you're thinking. WTF, Andre? But what is this? Kindergarten? I mean, come on, I came here to learn Python. Start teaching me Python. And I know. And don't worry, in this course, we're going to get you to have a professional setup with Python so that when you go into the workforce, you are doing what you're supposed to be doing. We're going to learn how to have all of these set up. First, we're going to have our terminal or command line where we can run Python from right in what we call a REPL. And then we're also going to use code editors like Sublime Text and Visual Studio Code. We're also going to use IDEs or integrated developer environments like PyCharm and Spider. And we're also going to use Jupyter notebooks. And I'm going to show you how to set up all of these on your computer, what the pros and cons of using each are, and how some of them might be used for machine learning while others might be used for writing quick scripts. And I know this is a lot, but it's good to have these skills depending on what type of job you want. And if you're a professional Python developer, well, you should be using most of these. But there's a problem if I start introducing this in the course right away. You see, these tools, you have to install differently based on what computer you have. So if you're using a Mac, a Windows, a Linux, maybe you're using a mobile phone. Because we want to get started right away and write some code instead of worrying about installations and making sure that your computer is all set up, I want to make sure that all of us can get started right away, no matter what device you're on. Now, if you're really keen, head on over to the section where I show you how to install all these on all of your devices so that you have it set up, and you can come back to this section. But I warn you, it's easy to run into problems and get confused when installing these tools. So I recommend sticking with what I'm about to show you, and I promise we will get you this professional setup. No other course is going to teach you all these things. But before I dive into these, we need to learn, well, we need to be able to just have fun and write some code. So what is this trick that I keep mentioning where we don't have to install any of these and still run Python? It's called REPL. You see, instead of us having to download this, we can go to repl.it. And when you go here, you'll get a login screen. Now, I recommend creating an account on here because, trust me, it's going to be very useful. It's one of my favorite tools. And it allows you to save Python files just online. For example, once you log in and create an account, you can just create a new REPL, choose the language that you want to use. In our case, we want to choose Python. We can name our REPL. So we can just call it hey, and we can just create our REPL and check it out. Right away, we have, without ever downloading this Python translation service, we can actually start writing Python right here in our browsers. And this is going to work for anybody that has an internet connection and a browser because this interpreter just runs automatically here. And the beauty with REPL is that, well, you can save these files, you can have different folders. So as we work through the course, you can actually have a folder for all your Python work and just have a really nice organized file structure that you can access anywhere you have internet connection. Now, if you don't want to sign up for repl.it, it's completely free. You can also use this open source glot.io, which again, you go to Python and you're able to run Python online. So take your time, sign up for repl.it, and let's get started with our first Python program. I'm finally getting there. In the next video, we're going to write our first piece of code. No more waiting. It's coding time. So I'll see you in the next video. Bye-bye. Hey, you're still sticking around. That's good. I didn't bore you with all my talking, but yes, in this video, finally, we're going to write some Python code. Holy moly, thank God, I thought that was going to last forever. All right, so what is our first program going to do? Well, let's create a very simple function. And probably the first thing any programmer learns to do, to print our own name. So in here, once you have your repl.it set up, or remember, you can also use glot.io, we're simply going to write print. And then you see over here that it gives us some information, but all we want to do is write brackets, a quote. So you can do double quotes here or a single quote, and just type your name. And if we click run, on the right side, we've just written our very first Python program. Very exciting. But what's happening here? Well, let's look at everything. First of all, if you're confused why my thing is dark and yours might be light, it's because if I go to settings, I've set my theme to light or to dark. I prefer the dark version. But you can change some of your settings. You can change the font size if you want. Based on when you watch the video, this website, the look might be different, but most of the settings should be the same. We see that we have a main.py, which is the Python extension. Any file that has a .py or py is a Python file. So what we've just written here on line 1 is a program that prints, in this case, Andre Nagoye, or in your case, your own name, and we've written it to this file. Now, REPL.it takes this file, already has this interpreter for us. It runs this piece of code, gives this source code of main.py to the interpreter, and runs it right here on our right side. If you look over here, we're using Python version 3.6.1. And down below, we see that, we have Andre Nagoye printed. That's awesome. So this is our code running. Remember this diagram. All we've done is we have our main.py, where we wrote print Andre Nagoye. We gave it to the interpreter that the REPL already provides for us. That interpreter takes our code, converts it into bytecode, and here it'll say Andre Nagoye, and then it runs it in the CPython VM, which was on the right side that we saw. And it finally prints our name because it tells the machine, hey, we want that text printed. So that's what we're seeing here. This is the CPython virtual machine essentially running this code and telling this machine, hey, I want you to print this. All right, but this isn't very exciting. I mean, let's make this program a little bit more dynamic. For our first program, we want to do something more impressive than just print name. So I'm going to teach you another thing we can do in Python, and it's called input. Now in here, I can say input, and you see that REPL actually gives me some information saying that, oh, I have this. You can just click here. And this input over here, well, what can we do? This input is going to prompt a user, and if I hover over it, you can see how it's giving me some information. But input simply gives us a way to capture information. So let's say, what is your name? And if I run this code, we see that we have our Python code running, and it's asking me, what is my name with this cursor here? So I can actually type something here. I can say Andre. And if I hit enter, well, there you go. I've just typed in my own name. Nothing that exciting, right? But this is where code becomes interesting because we can store this information on our computer. So again, these are things that we're going to go over in detail in our basics Python section. But just to write our first code, let's assign this to memory. That is, let's say that name equals whatever is the input of what is your name. And then finally, we can just print the name. So remember, the interpreter is going to take this first line. It's going to ask, what is your name? I'm going to type something. That typed information is going to get assigned to name. And then finally, we print name. Remember, an interpreter takes line by line, converts code to bytecode, and then finally runs it. So let's give this a try. I'm going to click run. All right, what's your name? My name is Andre. Did you see that? I typed in my name, hit enter, and then it printed out Andre. So for the final feat, let's greet. So we're going to say print hello, and then plus name. Now, don't worry about the syntax. We're going to go over it. But all we're doing is saying hello and then adding our name to the end of this. So let's see what happens. If I run this and say, what is your name? My name is Andre. And I hit enter. I get, hello, Andre, but no spaces. So let's add a little space, hit run again. For the fourth time, my name's Andre, and it says, hello, Andre. There it is, our first Python program. Now, it's not very exciting because it is our first program. We're just learning the steps here. But I hope, because we've covered some of these topics ahead of time, that this isn't just pure magic, right? You understand that this is source code. This is main.py that we give to an interpreter that runs our code line by line and then executes our program. In this case, our what is your name program. How cool is that? This is just the beginning. We're going to get more and more advanced here. See if you can play around with this. We don't know that much about Python yet, but I hope this gets you excited because, well, there's a lot more coding coming along. I'll see you in the next one. Bye-bye. Welcome back. Whenever you start to learn Python, it's unavoidable that you'll encounter this topic of Python 2 versus Python 3. So what is this all about? And it's a very important topic. Now, first of all, Python is created by a human, right? As a matter of fact, it was created by this person right here. His name is Guido. Now, a programming language is always evolving. It's not like somebody creates a programming language, it's perfect, and that's it. No, all programming languages are constantly being updated. Just like on your phone, you constantly get software updates. Well, a programming language is constantly evolving to make it better and better because nobody gets it right the first time. And by the way, this is a great video that I'm going to link to. You can check it out in the resources. Now, Python was created in 1991 by this gentleman, and it was actually created with the name from Monty Python, which was a British comedy group. But like I said before, the language is always evolving. And in 2008, Guido decided that, well, Python version 2, which has been used for a very long time, had some things that he and the community wanted to change. So in 2008, they decided to create Python 3, a new version of the language. Here was the tricky part. You see, when you update software, let's say on your phone or even on your laptop, you expect things to keep working, right? Updates are usually good, they're improvements. But some of the features that Python 2 had, they didn't like, or they wanted to change completely. So Python 3 introduced what we call breaking changes. That is, if you updated to Python 3, remember the Python interpreter, the C Python translator that we've been talking about? Well, as soon as you updated that, your Python 2 code wasn't really going to work. It's like updating your phone and then all of a sudden all your apps stop working. That doesn't sound very good, does it? That's pretty much what happened in 2008. Most companies that wrote their code in Python version 2 just kept Python version 2 because, well, for them to upgrade meant that they had to go through their code line by line and make some changes. Now, these changes weren't that significant. For example, I'll link to some resources, but don't worry, these are topics that we're going to cover throughout the course. But different things wouldn't work. For example, the print function, which we've learned about, in Python 2, it didn't have the brackets. It looked like this. And Python 3 used the brackets. So all the code that had print like this would break. Now, the differences themselves aren't that big. I mean, you can read through them and we'll talk about this in the course, but overall, you can learn them in a day. That's why when we learn Python, most of the time we're learning Python 3, but you can use the same knowledge with the older version of Python. Now, You may see some Python version 2 code out there for companies that haven't upgraded, but it's now what we call legacy. That is, come 2020, it's going to stop receiving security updates. So the community, Python community as a whole, is saying, hey, everybody start using Python 3 because we're going to stop maintaining Python 2. So we're going to learn the most up-to-date version 3 in this course, but we're also going to touch on some older topics that Python 2 covers, just in case you encounter them when you work for a company that perhaps still supports legacy code. But as I mentioned, the whole community as a whole is moving towards Python 3. This website, for example, shows you how many big packages, popular Python packages, which we'll talk about, support Python 3. In our case, there's only 4 popular packages that don't support Python 3. So what I'm saying is Python 3 is the way to go. It's the way of the future. That's what we're going to learn in the course, but I want you to be aware of the historical context. And one thing to be careful of when in this course you're searching for answers, or maybe I have some exercises that require you to Google things. For example, if we go to the Python documentation, which is the reference of what the programming language does, you'll see that you can choose the versions here. And you always want to go with the latest, but you might find some answers online that still use Python version 2. So you want to make sure that when you're searching for answers, that you don't encounter any legacy code. Like I said, 95% of the time, it's mostly the same, but you usually want to keep current with the language. It has the most community support, most up-to-date, most secure language. So, just a quick note about Python 3 versus Python 2. When you hear the word Python, people are generally just talking about both Python 3 and Python 2. And if you remember, in our REPL, when we created our first program, you see that you're using Python version 3.6. This is the default standard version that REPL comes with. So right away, we know that we're using Python 3. Awesome. It's up to date. It's new. The whole community is behind it. Well, most of the community is behind it. So we're all good to go. I'll see you in the next video. Bye-bye. Welcome back. Let's do our first exercise. And this exercise is going to be really easy for you to skip, but I do recommend that you actually do it. I know it's not coding, but it's important because you'll learn that teaching somebody a topic actually helps you learn. So this is the exercise. Based on the videos that you've watched, how does Python work? But don't think about it in your head. I want you to talk to somebody. I want you to teach somebody how Python works. So the first thing you're going to do is go to our community, our Discord community. We have lots of people here. We have about 1,500 people online right now, plus some alumni, plus some star mentors. Well, there's a lot of people. What I want you to do is go to the Programming Buddies channel, if you haven't already, and find a buddy. And with that buddy, whether that person is taking a Python course or taking a JavaScript course, it doesn't matter. Just say, hey, can I spend maybe 5 minutes teaching you how Python works? And see if you can explain it to them, how it works just like you've learned. And then, after you've done that, I want you to go find a friend or a family member that has never done programming before and see if you can explain in simple terms how Python works. That is, how Python gets written as source code. We use this translation service called an interpreter to run this code and then, spit out some instruction for our machines. I kind of gave away the answer, but you know what I mean. I want you to practice teaching somebody this because by understanding these fundamentals, it's going to help you learn more and more and understand how things work underneath the hood as we get more and more advanced. All right. First little exercise. It shouldn't be too hard. I'll see you in the next video. Now let's get started, shall we? In order for any programmer to learn a language, there are 4 key things that you need to really master for any sort of language, including Python. First are the terms of that language. Sometimes a programming language has different words and different definitions for these words that you're going to have to memorize. Things like statements, variables, instantiation. Really complicated sounding words, but you need to understand what they mean so that you can talk to other programmers. You also need to learn about a language's data type. That is, what sort of data can a program hold? You can think of it as values. Just like in real life, we have different ways to represent values, like numbers, letters, and symbols. In programming, we have these data types to store information. And each programming language has different sort of data types. Next, we need to learn about actions. At the end of the day, all programming is a way for us to tell our machines, hey, store this data and then retrieve this data and perform some action on it. That's all it is, just using memory and performing some actions. So we're going to learn how to perform those actions. And then finally, we have to learn the best practices of each language. There's good ways of writing Python code, and then there's bad ways. So that when we build our applications, our programs, well, we don't have a leaning tower like this, but we have a solid structure and a solid program. So throughout the course, we're going to learn about these things. But keep this in mind. These 4 things are what you need to become a good programmer. And I want to start the basic Python section with the data types. So let's get started. Let's learn about the Python data types, all the options we have in Python. Now we're back to our REPL.it so we can write some Python code. We see over here that we're using Python version 3.6. That's great. Let's minimize this and start writing our first Python code. Now, we're going to talk about data types. And Python has several available to us. Now, I'm going to list them out for you, and then we're going to talk about each one individually. First, we have something called int. And you see right away when I type, I have the REPL already give me hint, and it's highlighting it. If I hover over it, it shows me that int stands for integer. We also have something called float. We have bool, which stands for boolean. We have str, which stands for string. List, tuple, set, and dict. Now, what are these? These are data types, right? A data type is a value in Python. So you can think of it as exactly that, values. So int would represent all numbers, for example. String will represent all letters, for example. And a program is simply instructions that tell a computer what to do. And what does that mean? It's all about storing information, or a data type, and modifying that information. We're taking actions on these data types. So the 2 crucial steps when learning a programming language is that, well, we have these data types that we need to understand that exist in a language, and then we need to learn how we can manipulate the data, create, store, read, change, remove this data from the machine. Now, these data types are called the fundamental data types in Python. They are the core to the language. Now, after the fundamental data types, we also have something called classes. So beyond these data types, we can actually create our own using something called classes. So these will be custom types. Again, something that we'll learn about. So I can create a class that I can name whatever I want. For example, supercar. Now that doesn't exist, but I can create it. And we'll explore how to do that in the course. Now, Besides the fundamental data types, the classes, which will be our own custom types, we also have something called specialized data types. And these specialized data types, they're not built into Python, but they're special packages and modules that we can use from libraries. Now, again, this is a topic that we'll cover later, but these are, you can think of it as extra boosts. Whenever we don't have a data type that we want in the standard Python package, and maybe we don't want to create our own custom types, there are specialized data types that we can use from what we call modules. So you can think of it as extensions that we can add to the language. Again, something that we'll talk about later on in the course. And then finally, there's another type that is a little special called none. And none, as you can see, it's being highlighted, which means it means something in the language. None, as the name suggests, means nothing. It's kind of like the idea of zero in math. It's the absence of value. It's simply nothing. And you'll see why this is important in programming later on. So these are our data types that we're going to talk and we're going to use in our language. Now we're going to start with the fundamental data types, which are nice and simple for us to get through. So let's start one by one. And you know what? Let's start with these two for now. I'll see you in the next one. Bye-bye. Welcome back. Let's talk about our first data type. And you know what? Let's do two at the same time. We have int and floats. Int stands for integer, as you can see here, and float stands for a floating point number. Let's explore that. First, let's start off with integer. An integer is, well, a number. 3 or 4 or 5, these are all integers. In a programming language, you can use integers to do mathematical operations. For example, 2 plus 4. If I run this, well, nothing gets printed because, again, we have to perform some action on these data types. And one action that we've learned so far is this idea of printing. And we print something by calling the print keyword with the brackets. So the brackets is almost like saying, hey, perform this action on these data types. And if we run this, we get 6 right here. Awesome. So not only are we using print, but we're also using the plus sign to perform an action to add the two data types together. And as you can imagine, we can do most mathematical operations, the basic ones. We can do negative. We can do, let's say, 2 times 4. And then we can also do 2 divided by 4. And if I click run here, all right, it looks like everything is working. We've added, we've subtracted, we've multiplied, and then we've also divided. Now here's the interesting part. Up until now, we've used what we call integers. That is, these are whole numbers. There's no decimal places, they're just, well, integers. And a neat trick that I can do here is I can actually say, hey, what's the type of 2 plus 4? If I click run here, all right, let's decipher what just happened. I've taught you another action that we can perform, which is something called type, which tells us, hey, what data type is this? And just like in math, we go bracket by bracket. So the first part, Python says, hey, what's 2 plus 4? Well, that's going to be 6. And it's going to say, hey, what's the type of 6? Well, the type of 6, that's an integer. So it's going to say class int. We don't have to worry about the class keyword for now. That's something that we'll talk about later. But we see here that we're using int for integer. And then finally, after this gets evaluated by Python, we print out whatever this does, which is class int. Now, check this out. Let's do the same for all these ones as well. So we're going to say type here, and then type here. And if this syntax is intimidating, don't worry. This is something that you get used to. If this is your first programming language, it is not going to be easy because, well, if it was easy, then everybody would be doing it. So hang in there. Trust me, as you practice more, this is going to start making more and more sense. Now, before I click run, what do you think the output of each one of these lines are? Ready? Give it a guess and let's click run. All right, we got int for 6. We have -2 here, which is also an integer. We have 8 here, which again is also an integer. But then we have float, because 2 divided by 4 is 0.5. What is that? Well, remember, we are talking about 2 data types here. We're talking about int and float. And float is what we call a floating point number. A floating point number is simply a number with a decimal point. In our case, this is 0.5. So it's a floating point number. So if we write a number, let's say we'll do print type, and then I'll say 0.00001. What do you think we'll get? Well, we would get a float. If I do 5.0001, again, we'll get a float. What about the number 0? If I click run, I get an int because, well, there's no decimal points. Why do we need to make this distinction in programming, and specifically in Python? Well, it's because a float takes up actually a lot more space in memory than an integer, right? Because remember, this number, the number 6, this needs to get stored in memory on our machine. And remember that machines don't really understand this. They understand zeros and 1. And they store this number in something called a binary, or binary numbers, which is zeros and 1s. Now, the problem is when you have decimal places like 0. Or let's do 10.56, it's hard to represent that in a binary number, zeros and 1s, because of this point. So a floating point number essentially stores these numbers in 2 different locations, one for the 10 and one for 56. Now, we don't need to get technical here, but that's the idea. The idea is that we need more memory to store a number like this than a number like this. Now, the topic of floating point numbers is really, really interesting, and I'll link to a resource. But the best way to learn more about floating points, again, it's not super important that you know the technical details. But if you go to floating point number Python, again, you want to make sure that you go to the documentation for version 3. And you can actually learn about floating point arithmetic. And these official documentation by Python are always a good tool for you to use whenever you get confused about something or you want to get a little bit more extra detail. But let's get back to the topic at hand. Both int and float are used for, well, numbers, right? And Python is going to automatically format the type to whatever, well, makes sense. For example, if in here I do 20 plus 1.1, one is a integer, the other one is a floating point number. But when I click run here, automatically Python is going to convert it to float. Let's remove these here so that we don't get confused by them. So if I run this, we see that this whole expression is converted into, well, a float. Now, if I do, let's say, 9.9 here, which will equal to 11, and I click run, these two floats add up to, well, still a floating point number. Because if I remove the type from here, and I click run, it gives me the result 11.0. It keeps the floating point numbers. All right, but at the end of the day, what we care about is that Python works the way we expect it to. That is, we can do mathematical operations. As a matter of fact, we can do a few other things as well. There's also this idea of the double multiply. So this means to the power of. So 2 to the power of 2, well, that's going to equal 4. 2 to the power of 3 is going to equal 8. We also have the double divide. That is, we can do 2 divided by 4. But then we use 2 slashes here. If I click run here, I get 0. This actually returns an integer, rounded down. If I do 3 divided by 4, I get 0. But if I do 5 divided by 4, I get 1. This gets rounded down to an integer. Finally, the last operator that we're going to learn about is called modulo. And it looks something like this. If I do 5 modulo, which is the percent sign, divided by 4, or modulo 4, if I run this, I get 1. Modulo is used to represent what's the remainder of this division. So if I divide 5 by 4, the remainder of this division will be 1. If I do 6 divided by 4 with modulo, and I run, I get 2. 2 is the remainder of 4. All right, let's take a break and learn a little bit more about these numbers in the next video. Bye-bye. Welcome back. Let's continue our understanding of int and float. We talked about the idea of these two data types and how we can use operations on them that we're familiar with from math class, plus a few ones that maybe we haven't seen before, such as modulo or the double slash, or the double multiply for the power of. Now, this is really cool because we can get our computers to do, well, math for us, like a calculator, right? But a programming language also provides for us different actions that we can perform. Now, besides these ones, we also learned that there's a type action that we can take, there's a print action that we can take, but there's also specific math type functions that int and float are able to use that are built into Python. Now, these are called, well, math functions. And functions, something we'll talk about later on, are these actions that we've been talking about. Remember our diagram here? We're starting to learn about the data types and the actions that we can perform on them. Now, in most programming languages, these actions are called functions. And we have a whole section on them. But for now, there's some functions that we can use. So this is a print function, this is a type function. But there's specific math functions, such as round. And you see right away when I type, REPL is a tool like an IDE that hints and tells us what we can add. So it says round and give me a number and maybe an nth digit. But let's just worry about the first one for now. So round, if I do 3.1 and I round here, I get 2. Well, that's not right? That's actually the result from up here, because we need to also tell it to perform with a function of print. Hey, print to the screen whatever the result of this is. And just to make things easier to see, I'm going to comment this out. So I'm just selecting everything and then pressing Command/, or if you're on Windows, Control/. If I click Run, I get 3 because I'm rounding down the number. So let's say if it was 3.9, I click and I get 4. Again, I'm rounding the number. Another math function that's built into Python is something called ABS. And you see right away that I get ABS here. And ABS returns the absolute value of the argument. And again, for those that aren't too familiar with math, an absolute value simply means, well, no negative numbers. So an absolute value of -20 is 20. And now, because we know about math functions, I can start Googling, right? I can say, hey, I'm a Python programmer and I want to learn about math functions. Well, I can go Python 3 math functions. And look at that. Right away, Google tells me that there's a ton that we can use. You don't have to memorize all of these. As a matter of fact, some of these I've never ever used in my programming career. But it's good to know that they have these tools available to you. And as a programmer, this is something that you'll have to get used to. The idea that you won't actually memorize every single action that we can take for each data type. Because some of these are very rarely used. Some of them you'll never use in your career. The key is to understand how to Google them and how to find them. And throughout this course, I will show you the important ones that you're going to see over and over and over. But as a way for you to develop as a programmer, at least you know that this is how you look for answers and find out that, hey, there's different math functions that we can use with numbers. All right, let's take a break and continue in the next video. Bye-bye. All right, this is a big video. Now, these videos are going to be sprinkled throughout the course. They're developer fundamentals video. These are the topics that are going to be super, super short, but important because as a beginner, it's hard to learn these things because you don't know what you don't know. So what I'm going to try and do in these developer fundamentals is tell you, well, how to avoid the mistakes that I made when I got started. And what a lot of people do when they get started. That is, they don't have a clear path and don't understand what the most efficient way to do things is. So with developer fundamentals, we're going to talk about key things to make you, first of all, efficient in learning Python, but also make you a programmer that is really, really good and that companies want. So what is this first developer fundamental? It's don't read the dictionary. What does that mean? Well, when you're learning a language, such as Python, you're going to have a tendency, especially when you're starting out, to try and learn every single thing, every single function, every single syntax, every single trick. It's almost like you're trying to learn a language by reading a dictionary from page 1 all the way to page, 1,200. But that's not how things work. As a matter of fact, when I work with different programming languages, I don't know all the syntaxes. I don't know all the methods and functions. And what a lot of developers do is not necessarily memorize everything, just like you would every single word in a dictionary. Instead, you understand what exists and what you can use, but you can always Google things. And most of the time, developers are Googling things, no matter how experienced they are. For example, if we go to the Python documentation here, we can go through everything, right? I can go through the language reference and read through everything. And this is really, really useful information. But you're not going to memorize every single thing about the language because there's a lot. This is the Python language, and then there's also the libraries, the standard libraries that we can use. And if you sit through here and just read everything in here, well, you're not going to memorize anything. In order for you to actually learn Python, you have to use the language. And you'll notice that some things are used a lot more than others. Just like in human languages, like when you learn English, there's really difficult words that don't get used that often. And there's words like and, the, or apple that get used very often. So we're going to learn the language in a way that makes sense, in a way that's efficient, where we focus on the 20% that gets used 80% of the time. And all these smaller, more complicated things we're going to cover, but we're not going to cover one by one from start to finish. We're going to jump around. The idea being that when you learn a programming language, you're just using these concepts and slowly you're learning what's out there so that when you have a problem, you can identify it and remember, oh, I think Python has a pathlib library that I can use. Or perhaps remember that, oh, I can use tuples in Python. So your first developer fundamental is this. Don't learn a language as if you're trying to get 100% on a test. We're going to learn a language by actually using it, focusing on the things that actually matter. All right, that's enough talking for me. I'll see you in the next video. Bye-bye. Welcome back. Let's talk about an important term when it comes to programming, and that is operator precedence. Now, what does that mean? Again, we're using our knowledge from math class. It's the idea that if I do 20 plus 3 times 4, it means that different operators have precedence over different ones. That is, we multiply this first, equals to 12, and then 20 gets added to 12. Because the Python interpreter is going to follow a basic set of rules. For example, if I do 20 minus 3 here, and let's print this out, click run, I get 8. Because 3 times 4 gets evaluated first, which equals to 12, and then subtracted from 20. It's not that this goes first and then we multiply 17 by 4. And this operator precedence shouldn't be new, right? If you've taken any sort of math class, you understand that this is how, well, math works. And this works the same in all programming languages. So the order is this. First, we follow the brackets. So whatever is wrapped in a bracket, we do first. The second is we do the power of. So whatever is done in the power of will be after parentheses. For example, if I do parentheses here, and then to the power of, let's say, 2, or let's do plus 2 to the power of 2, well, the first operation that will happen is 20 minus 3, because that's the first precedence. And then we do 2 to the power of 2, because that's the next precedence. And then only after we do that, we add these two together. If I click run, I get 21, which again makes sense. 17 plus 4. After the power of, we have the multiplication and division. And then finally, the last precedence is addition and subtraction. Now, this isn't going to be a math class. Some people really love math. Some people really don't. But I want to just give you this basic understanding of operator precedence when you see it. We'll do some exercises here to get accustomed to it, but trust me, this is as mathy as we're going to get in this course. The math part of the course is, well, just here. It's going to get a lot more interesting as we learn about different data types. I'll see you in the next one. Bye-bye. Welcome back. This is a quick optional video that, well, with something that you probably won't use, but I want you to just know that it's out there. And that is, there's actually an extra data type that I didn't talk about, and it's called complex. And as the name suggests, it's pretty complex. However, a complex number, again, is a number that is a third type. Instead of int and float, we also have this type for numbers. Now, the reason I'm not really teaching complex is that you only use this if you're doing something really, really complex math. Most of the time, you'll never use it. I personally have never used it, but it is good to know that it exists. It's the equivalent to a real number, and you can read about complex numbers if you want. But again, that's something that you don't need to worry 99.9% of the time. Another thing I want to talk to you about is this idea that these integers and floats get stored, such as 5, in memory as binary. That is, as binary numbers, ones and zeros. And there's actually an action or function that we can use in Python called bin for binary. And you can see that a bin returns the binary representation of an integer. So it's going to return whatever the binary version of 5 is. If I click run here, well, I have to print, remember. So let's print and click run, and I get the binary representation. Now, instead of all zeros and ones, there's also this idea of b. And that is what Python uses underneath the hood to say, hey, when I see this number with 0b, that's a binary number. But if I Google binary number 5, I see that the binary number for 5 is 101, which, again, that's what we see here. So that's really cool, really interesting just to know that it exists. By the way, just for fun, let's say that we want to return this into a decimal. Let's say we're the computer and we just retrieve this binary number. I can do int and then wrap this like this in single or double quotes. And then with the int, I can also say, hey, I want this return to a number that is base 10, which is what us humans use. So if I actually do print here and click run, well, actually we have to do base 2 here, right? Because what we're saying is, hey, this number is base 2 and convert it to integer. And base 2 number is, well, zeros and 1. It's a binary number. So if I click run here, look at that. I get 5. So in your head, you can think of it this way. When we store a number like 5, an integer like 5, when a computer retrieves that number, let's say we're doing some addition, well, it's going to grab this from memory. It's going to say, well, this is a binary number, and I'm going to convert it into integer. Very, very cool. Now, the reason I taught this here, you won't see this a lot in beginner courses, and especially so early in the course, but I think it's an important principle. Although you might not get tested on this ever, for you to just understand how things are working underneath the hood, I believe is an important thing for you to do in order to become a great developer. So hopefully this doesn't confuse you too much. I'll see you in the next video. Bye-bye. Welcome back. So we've just learned about the first 2, well, kind of 3, because we also mentioned that there is such a thing as a complex number in Python. But we talked about the main ones, the int and float, and there are still a few data types remaining. But before we get to these, we are missing an important concept. And this is going to be our first important term in Python, and as a matter of fact, in all programming languages. It's called variables. Yep, that's a term. Now, if this is your first time learning a programming language, you might not know what this means. If this isn't your first time, well, this is very simple because all languages have variables. But what are they exactly? Well, variables store information that can be used in our programs. So we can hold perhaps user inputs like values. Maybe when you log into Facebook, you need to hold some information such as your profile picture or maybe your date of birth in a variable. Variables are ways for us to store information on our computer. So let's have a look at this. If we remove this, and let's say I'm creating a quiz program. And this quiz program maybe measures your IQ. And let's say you just took the quiz and you found out that your IQ is 190. Quite high, good job. But we need to store that information somewhere. Well, we can do that with variables. So that in Python, all we need to do is name it whatever we want. In our case, it'll be IQ. And we're going to say IQ equals 190. And this IQ here is a variable. It is something that I just completely made up. I could name it whatever I want. That's a variable too. The idea is that once we assign to a variable, that is, we're saying 190 is going to be assigned to IQ, I can now use it in my program whenever I want. For example, I can later on print, or make sure it's not cap, let's do print IQ. And if I do that and click run, you see that I can use IQ. So we can pretend here that a user takes a quiz, finds out their IQ is 190. We can store that information in this variable, and later on, when they come perhaps online or try to use the program again, they don't have to take the quiz all over because, well, we store that information in IQ. And remember what I said at the beginning. Programs are simply data that's being stored, that's being changed, that's being removed, and that's all programs are. And variables are important concepts in Python and all languages. Now, variables can also sometimes be called names. So this could be a name, for example. And assigning a value is also known as binding. That is, we're binding the value 190 to this variable so that when we request this variable later on in our program, our computer knows how to look for this information. It's going to say, hey, I know what IQ is. I stored it somewhere in memory. And it's going to go look for that. And because it's being bound to a value, it points to this value 190. And remember, this number in memory gets stored as a binary representation in zeros and ones, right? But it doesn't matter to us because however our machine stores it, we don't care. We just want to be able to retrieve it. And then when we print it to do, well, get 190. Now, we're going to be using variables all over the course. But on top of just naming variables however we want, there's some best practices around variables of how you should write good variables. And as a matter of fact, these are specific rules that the Python community as a whole has that you'll just have to remember. So let's have a look at this. Variables, and remember, this is the symbol for best practices, are what we call snake case. Snake case means it's all lowercase and then spaces, well, they don't exist. We use underscores. Variables must start with a lowercase or an underscore. Variables can be anything with letters, numbers, and underscores. But remember, they have to start with lowercase and underscore. That means we can't start a variable with a number. They're also case sensitive. That means if I create a variable, but let's say this snake case, this variable has a capital E instead of a lowercase e, that'll be a different variable. And then finally, you can't overwrite keywords. Let's go through these with some examples. First, a variable has to be in the form of a snake case. That is, if I want to call this user IQ, I should technically have an underscore here instead of a space, just to make sure that a programmer, maybe I'm working on a team, can read this variable. So that's snake case. You also have to start your variables with either a letter or an underscore. So I can technically do this. And I click run. Well, that's going to give me an error because I've changed the variable. So now in order to access that variable, you have to go like this. Now, underscore in Python signifies a private variable, something that we'll go over later on in the course. But usually you're starting your variables with a letter. And afterwards, yeah, you can add numbers if you want in here. That's no problem. This is still going to work. This is a valid variable. Finally, a variable is case sensitive. So if I do user IQ here, and I do capital letters, I can't access this like this because, well, it doesn't exist. Again, it's case sensitive. We have to make sure that we match. And finally, we don't want to overwrite keywords. What does that mean? Keywords in Python, well, they already mean something in Python. For example, this print is a keyword. You can see it highlighted in blue. So that if I create a variable saying print equals 190, and then I do print, let's see what happens. We get an error because I can't really assign to this variable because print already means something. Now I know what you're wondering. What are these keywords in Python? That's a simple Google search away. And we'll learn these throughout our course. If we go to Python keywords by WE3 Schools, you'll see that we have these keywords that each mean something in Python. Again, we'll go through these and we'll learn them throughout our course. And if you look, it's not that intimidating. There's not that many. So as we practice, you'll start to get familiar with them. But the easiest way to tell whether it's keyword or an important word in Python, well, you see that it's highlighted in blue. As soon as you create a variable that is unique, it's highlighted in white. And this will be the case with whatever environment that you're typing code into, as long as it's set up for Python. Now, beyond the Python keywords, there are different things like, for example, the int for integer that we've learned. So these we're going to get familiar with. So a good rule of thumb for variables is to make them really descriptive. Really say what your intention is. And a good programmer is somebody that's able to name things really well with their variables. So if a new developer comes and looks at your code, it's easily understood. Finally, variables can also be reassigned. For example, let's say we have IQ here of 190, and then I decide to perhaps have another variable, call it user age. And for some reason, I want to assign user age to perhaps have IQ divided by 4. Is that going to work? It should, right? I'm saying user age is going to equal 47.5. I'm using IQ, which is 190, dividing it by 4, and then assigning it to user age. I can maybe assign this to another variable called user age or called A. And once again, I run this and it's printing the same thing. So you can use variables to store that information and use it whenever you want. You can use it in operations, you can use it to reassign it, whatever your program needs. Now, later on in the course, we're going to learn about classes, and classes actually have a different convention than this, but we'll get to that later on. For now though, I want to mention 2 small gotchas with variables that you should be careful with. For example, there's an idea of constants. And constants are those things that never change in a program. For example, if we wanted to create a constant, such as the value of pi, let's say for now it's 3.14, we can have it all in capitals. And that's going to tell other programmers that, hey, this is a constant. This number is not meant to change. I mean, we could change it if we want. There you go. I just made pi equal to 0. So it was stored as 3.14 in memory, but then we overrode it and reassigned it the value of 0. You can still do that, but a good convention is that if you see this, that means this number or this value should never be changed. Another type of variable that you're going to see, and this is something we'll see later on in the course, are it doesn't look like I just did double underscores here, but it's 2 underscores, and we call these dunder. And as you can see here, we have some dunder variables that Python has. Now, we'll learn more about these later on, but the idea here is that these are meant to be left alone. You should not touch them. You shouldn't create a variable with 2 underscores like this and call it hi and assign it a value. I mean, you still can, however, this is generally not good practice. So you want to be careful with that. But the one thing that I really want you to take away from this is that variables are really important concepts in programming. Naming variables is one of the most important skills you have as a programmer. I know it sounds silly, but there's so many times that I read code that is so hard to understand simply because a programmer is not descriptive enough. So throughout the course, we're going to learn how to name things well so that our code reads like English. And that's the whole point of writing good code. The point of writing good code is that it's readable and understandable by other programmers. By the way, to finish off, I just want to show you one quick trick. There's also a way that you might see in some code bases that uses something like this. Equals 1, 2, 3. And this simply is a way for us to rapidly assign values to variables multiple times. So for example, if I do print A, then print B, then print C, and I run this, you see that I get 1, 2, 3. We assign value of 1 to A, value of 2 to B, and value of 3 to C. Just a quick shorthand way that you might encounter. All right, let's take a break, and I'll see you in the next one. Let's learn another important key term. Well, 2 for that matter. One is expressions, and the other one is statements. You're going to hear this a lot when talking to programmers. So what do they mean? Let's have a look. If we create a piece of code here, let's just say IQ is 100. IQ has lowered. And then let's say user age is going to equal IQ divided by 5. An expression is this part of the code. It's a piece of code that produces a value. In our case, this produces a value, right? Because 100 divided by 5 is going to equal 20. So this is an expression. A statement, on the other hand, is an entire line of code. Not this entire thing, but an entire line of code that performs some sort of action. In this case, what action are we performing? Well, the action is that we're calculating 100 divided by 5 and then assigning that value to the variable user age. So this is an expression. This is a statement. And also this is another statement. So if you hear me mentioning these terms throughout the course, hopefully now you know what they mean. I'll see you in the next one. Bye-bye. Welcome back. I want to quickly talk about something called augmented assignment operator. So we've learned that we can create variables like some value, and we can assign it a data type. In our case, let's just assign it 5. There's something called augmented assignment operator that allows us to do something quite neat. Let's have a look. So if this value, I want to increase it, let's say 5 plus 2, so add 2 to it, I could do that. Or I could even use some value which is already 5 by the time it gets to line 3 and do something like this. If I print some value and I click run, I'll get 7 because 5 plus 2 equals to 7. So in memory, some value points to 7. But there's a neater way of doing this called augmented assignment operator. Instead of doing something like this, I could just simply add a plus to the equals. So we're going to say some value plus equals 2 is still going to equal 7. So it's the same thing as before. And this is called augmented assignment operator. It's a shorthand of us doing something like this. We can also change this to something like minus, which once again is like subtracting 2 from whatever the previous value of some value was. Now, if I was to do this at the beginning here, so let's just do here and then comment this out. And if I click run, I'll get an error because some value is not defined. We haven't really created anything. So in order for this to work, we need to make sure that this variable has some previous value. So we've learned about the plus, the minus, and then finally we have the multiply. Once again, if I run this, we get 10. Remember, this is just the same as us saying some value times 2. It's just a shorthand form. All right, this was a quick video in case you see something like this in the wild. Now, you shouldn't be afraid. Remember that the operator comes to the left of the equal sign. I'll see you in the next one. Bye-bye. All right, we're almost kind of flying through this. I know we're going slow here, but trust me, once you get these data types, things become a lot easier. So we're just climbing that mountain so that we can start looking at a higher level at the language of Python. To keep going, let's talk about this data type, str, which stands for strings. Let's see what they are. A string is simply, well, a piece of text. For example, a string can be written with quotation marks. And I can say, hi, hello there. And that is a string. You see that the color changed here in my editor. I can also make strings with double quotes. So once again, this is also a valid string. And I can put anything I want in here. I can do numbers if I wanted to, exclamation marks. It's just a piece of text. You can think of it as a sentence for now. And if I do the type function here, remember, these brackets denote that we want to perform some sort of action, which is we're using the type action that Python gives us. And if I click run, you see that, and remember we have to print it out as well. So let's do print so that we can see the display. And I click run, you see that it's str. It's a type of string. And now we can use this in important ways. For example, imagine you're creating a login form and we want to collect somebody's username and password. Well, we can have username variable that we assign, let's say, some sort of username. Let's call it supercoder. And then password can be super secret. And now we have these variables, usernames and passwords that we can use throughout our program, such as to check if a password exists. And remember, I can use single quotes or double quotes. But there's a third way that we can write strings in Python. And this, well, is used for long strings. So let's just create a variable long string. And what we can do here is 3 single quotes in a row, like this. And then here, I can just say, wow, maybe a pair of eyes of somebody that's really impressed, and let's go with a mouth. That actually kind of looks like hair. All right, and then I finish it off with 3 single quotes again. So now if I print the long string and I click run, look at that. My little weird emoji face is printed. So the 3 single quotes is for long strings that I can keep going on multiple lines. For example, I can't do this with the single quote. You see that the orange color is now gone because Python is going to say this is a new line and this is another line. And it's going to give me an error because, well, a cret with a quote doesn't mean anything. But if we use 3 single quotes, you can see that we can do multi-line strings. And this is really useful if you want to have maybe long sentences and paragraphs. Now, with a string, we can do some cool things that we saw in the numbers videos. What if I had something like this? Let's say I wanted to grab the first name of a user. I'll just give my own name here, and then last name. And again, my super hard to pronounce last name. Could we do something like this, where we have full name equals to first name plus last name? And then if we print here the full name like this, should this work? Well, let's have a look. Let me remove this part over here just so we have nice and clean looking code. And if I click run, there you go. My name is printed, but you see that there's no spaces here because we're going to use the addition sign to attach Andre to Nagoye, but you can see that there's no spaces here. So I can add a space if I wanted to, or I can just simply create another string inside of here, just like this, and then add a space in between. So we're just using the plus sign, which we've seen in the numbers videos, but instead to add strings together. And now if I click run, you see that I got the space because I'm adding a space in here, in between the names. Very, very cool. But there's a few more neat things that we can do with strings. So let's take a break, and I'll see you in the next video. Welcome back. I want to quickly touch on the subject of what we call string concatenation. Yes, programmers love creating really complex names when concepts may not be as complex. So what does string concatenation mean? Well, it simply means adding strings together. So I can do hello plus Andre, and I've concatenated the string. I've added 2 strings together. So if I print this, I get hello Andre. So if you ever hear people talk about string concatenation, that's what they mean. We're concatenating strings. By the way, what do you think will happen if I do hello plus 5? If I click run, that's not good, is it? I get type error. Must be string, not int. So it looks like string concatenation only works with strings. We'll explore that a little bit more in the next video. Welcome back. Remember in Python that string is written as str, and this is a special word. Actually, it's a built-in, what we call function, or built-in action that we can take. Now, let me ask you this. What happens if I do string 100? 100 is clearly a number, an integer. But what if we run the string function on this? Let's find out. Let's do print here, and then run this. If I click run, I get 100. All right, but is this an int or a string? To find that out, once again, let's wrap this, so the answer of whatever this value is, into type, like so. I know this is a lot of brackets, but remember, we're evaluating this piece of code, so we're turning 100 into a string, or running the string action, and then we're going to check the type of this entire thing, and then we're going to print it out. If I click run, I see that it's a string type. So we've converted 100 into string using this. Now, just to confuse you a little bit more, what if we do something like int like this. All right, even more brackets. What happens now? Can you guess? Well, we convert 100 into a string, then convert it back into an integer, and then we check the type of it, which is a class int, and then we print that. So remember, this was the same as me saying a equals str 100, and then b is going to equal int of a, because we're evaluating this part. And then I'm saying c is going to equal the type of whatever b is. And then finally, we're printing c. So that piece of code was the same as doing this. Very, very cool. Now, this is the idea of type conversion. Again, if I were to write that down, it's called type conversion. We're converting the type of our data types. And you can do that throughout programming. And we'll talk a lot about this throughout the course. But it's the main reason we have things like str, int, we have things like float, and many other data types that we're going to talk about. I'll see you in the next video. Bye-bye. Welcome back. Let's talk about something called escape sequence in Python. Let's comment this out. And let me ask you a question. What if we wanted to have a string that tells me, let's say, the weather? And here we want to write, it's sunny. You see how the highlighting changed here? Because I want to say it's with an apostrophe s. But Python is reading this and saying, okay, this is the start of the string and this is the end of the string. And then I have no idea what this is, and then we're starting a string again. How can we fix this? Well, we can add a double quote string instead, and this now works. But what if, for some reason, we also wanted to add it's kind of sunny in quotation marks? Well, now we have another issue. So how can we solve this? Because in human language, we have double quotes and apostrophes. Well, we can use escape sequences here. And this is a little hard to understand at first, but it's simply adding a slash like this. So the one right above your enter on the keyboard. So this slash, when Python goes through it, is going to say, all right, whatever comes after this, I recognize this symbol. Whatever comes after this, I'm going to assume it's a string. So now if I do backslash here, and then backslash here, it's going to say, hey, Python, I'm letting you know whatever comes after this is a string. I'm letting you know whatever comes after this is a string. And then I'm letting you know what comes after this is a string. So that when we print the weather, everything is printed nicely. Awesome. Now, this escape sequence can be used in multiple ways. For example, if I want to have an actual backslash, well, I can go like this. And because it's saying whatever comes after this is a string, it's going to assume that this is a string now. So if I run this, you see that we get this backslash. And there's a few other neat tricks that you can do with it. For example, one of it is the backslash t. What does that mean? Well, let's remove this for now. There you go. The backslash t, remember, well, let's add a space in here so we can distinguish it, is going to say, hey, whatever comes after this, I want you to add a tab. This is a special meaning here. So if I click on run, you see that it's added a tab spacing to my string. Another one is using n, or a new line. So let's leave t here and then add a backslash n and then say, hope you have a good day. What do you think will happen here? If I click run, I have a tab from the \t, and then I have a new line after kind of sunny because I do the \n, which denotes a new line, so that this shows up on a new line. Now, these escape sequences are hard to see at first, but they're pretty much available in all programming languages that use strings. So if you come from another language, this shouldn't be that strange to you. If it's your first time seeing this, you just need to get used to this syntax, and every once in a while, go to the Python documentation and just type in escape sequences, and you'll see all the ones that we have. These are the main ones that you need to know. All right, more to learn in the next video. Welcome back. Let's talk about the topic of formatted strings. Up until now, we've just written simple strings. But we want a program that's dynamic, that's static. Let's say we have a Amazon page, and we're working at Amazon actually. And when a user logs into their profile, well, we want to display their name or what they have in the cart. In that case, we don't want to just hard code and write every single user's name, like Andre, or another user, Joe, and write every single name in the world. No, ideally, what we can do is have something dynamic, where let's say it's a profile page and we simply use the name variable and we display that on the page. Now, this name variable should equal whatever the user's name is. And this is something that we can grab from the database, again, something that we'll talk later on in the course. But let's assume that in here, when we do equals, we're going to grab some user information, which will be the name. And this name, for now, will be John. Or let's go Johnny. And this Johnny, we want to display on the profile page. And we can do that with formatted strings. We can simply do something like print and then say name. But we also want to greet that person, right? So let's do hi and then plus name. And remember to add a space. If I click run, I get hi Johnny. But as we get more and more information, let's say we have age and Johnny is 55. If I wanted to extend the sentence and I want to say you are, and then add another plus, make sure we add a space in here, and then add year old. Run here. All right, we get a type error. Must be string, not int. Oh boy. All right, so we have to convert this into a string. So remember, we can do that like this. And then if I click run, hi Johnny, you are 55-year-old or years old. All right, that was a little cumbersome, but we're making our Amazon page dynamic. We can grab different information from the database and we'll have in a string something according to the user. But there's a better way of doing this. And with formatted strings, all we need to do is add an F at the beginning. And this F at the beginning is going to tell Python, hey, this is going to be a formatted string. And instead of doing all this plus and name and all this stuff, and doing the str to convert the type, we can simply do something like this. Let's remove this and simply do brackets and say name. And then again, remove all of this and say age. So I'm going to say hi, name, you are age, years old. And if I click run here, you see that it still works. This is a new feature of Python 3. By adding F to the beginning, it's saying, hey, this is going to be a formatted string. And I want you to just make these variables available as strings inside of, well, this string. How much cleaner is that? Now, although this is nice and clean, and this is my preferred way of writing strings, before Python 3, you didn't really have this. So in Python 2, and mind you, this works in Python 3 as well, as you can see, we had something different to accomplish this. What we had was this idea of a dot format. And dot format, so let's remove the F here, is going to do the same thing for us. We do a bracket here, and then we say, hey, we want Johnny and age of 55. And we can just remove these variable names. If I click run here, I get an error. And you have to be careful here. Dot format works on strings, but you can see over here that we did it outside of the brackets. And what it's doing is saying, hey, run the format action on this print. But print is not really a string, right? So you have to make sure that we move the brackets to the outside so that we evaluate this piece of code first. So the string is going to get formatted, and then we're going to print. If I run this, hi Johnny, you are 55 years old. So that works the same way. But what if we wanted to use variables? Because right now we're just doing this by order. So whatever comes first gets filled in first in the brackets. Well, we can do something like name and age. Let's see, can we do that? Let's run. There you go. That works the same way. What if we had a specific order? Maybe we want this to be age and here to be name. Well, we can mix those around. We can say 1 here and 0 here. Because in computer science, we always start counting from 0. So this is 0 and this is 1. If we had something else in here, let's say a third variable, then this will be 2. So if I click run here, all right, everything is upside down. Finally, I can just create my own variables if I wanted to. So let's say hi, let's say new name equals Sally. And then age of Sally is going to equal, let's say 100. Sally is very old. Now, if I do 0, let's say I'm 1 here, if I click run. So now we'll actually get an error, tuple index out of range. Now we haven't really learned about tuples and ranges, and this is a little confusing, but a bit of a trick here. We want to make sure that we add now, because we've given the actual variable a value, we need to actually say new name here. And here will be age. So that if I click run, there you go. Hi Sally, you are 100 years old. As you can see, with dot format, things are a little bit more complicated. You'll still see this, and all Python 2 code still uses the dot format. And you'll see a lot of Python 3 code bases that still use dot format because some people prefer it. But I would argue that the F at the beginning of a formatted string is the way to go because, well, it just makes things so much easier, right? Nice and clean, nice and easy. So I do recommend that you use the formatted string with the F in front. And for short, we usually call this an F string. All right, I'll see you in the next one. Bye-bye. Now, up to this point, we've learned that str is an ordered sequence of characters, right? It's essentially a piece of text where we can write our names, passwords, paragraphs, and sentences. And strings underneath the hood are stored in memory, as I said, as an ordered sequence of characters. So for example, if I had the string me, then this will be stored in our computer's memory in an order. So M will be stored in a place in memory, and after that place in memory, E will be stored, then the space will be stored, and then M, then E, then space, then M, then E. So if you think of a bookshelf, each one of these is ordered in a different part of the bookshelf, but one after another. And the way we can think about this is like this. The M is stored in location 0, and then E is stored in location 1, and then space is stored in location 2, and so on and so forth. And each shelf now corresponds to a value. So that when we ask the computer, hey, I want you to grab this string, we know that, hey, we're going to look in the shelf 0 to 7. Now, why is this important? Because one of the most useful things you can do with strings is to access different part of a string using its what we call an index. So for example, when you have a string, and let's call this variable or this piece of string selfish. And selfish has me. And I'm going to comment this out just like this. Make sure it's aligned, okay? And what I'm going to do here is I'm going to say selfish and then square brackets right here, and then type in 0. Now, if I print this and I click run, check that out. I get the letter M. Why is that? Well, using the square brackets, I'm telling the computer, hey, grab the variable selfish, and then from that variable selfish, grab whatever is an index of 0. And what's on that bookshelf of index of 0? Well, the letter M. What if I do 7? What do you think will happen? If I click run, I get E, because on the bookshelf of number 7, that's E. And when I'm getting just selfish, I get the entire string. It's going to say, all right, I'm going to grab from the bookshelf index of 0 all the way to 7. Very, very cool. And this concept we're going to explore throughout the course, and you're going to see why it's important very soon. But using this knowledge, we can do a lot of string manipulation. And Python has this unique feature that we're going to talk about right now that allows us to grab different pieces of text. So let's have a look here. The rule here is when we use square brackets in Python, the first item that we put between the square brackets is what we call the start. The start is, hey, where do you want me to look? In our case, we said we want to look at 0, so we got M. We wanted to look at 7, we got E. But then there's an extra thing that we can do. If we do a colon here, we also have the option to say, hey, where to stop. What does that mean? Well, if I do something, and you know what, let's change this to 0, 1, 2, 3, 4, 5, 6, 7, just so it's easier to understand. If I do, let's say, 0, colon, 2, and I click run, I get start at 0, end at 2. So I get to grab 0 to 1. Because remember, I'm saying start here, but then stop as soon as you get to bookshelf 2. We don't want that. So if I do 0 to 7, what do you think will happen? Well, I click run, and I get all the way to 6. So in order for us to grab the full string, we have to do 0 to 8. Because there's actually 8 characters here, right? Because we start from 0. If I click run, there you go. Now there's a third thing that we can add here. And this is called the step over. And the step over says, hey, start here, end here, and then step over a few things. So the default is 1 because we're going 1 by 1 through our bookshelf. You see that we get the entire string. But if I add 2 here, it steps over by 2. So I grab 0, then I step over 1, 2, grab 2, then step over 1, 2, grab 4, step over, and so on and so forth. So let me ask you a couple of tricky questions here. What happens if I do this? Is this valid? If I click run, what will happen? Ready to guess? I get 1, 2, 3, 4, 5, 6, 7. This says, hey, start at 1, so that is right here. But then afterwards, stop, well, there's nothing there. So the default is going to say, go all the way to the end. I know this is confusing, but hang in there. Practice this often enough, and this will become second nature. Okay, what if I do something like this, where I don't fill the start and do 5 here? What happens now? Ready? I get 0, 1, 2, 3, 4, all the way until 5. So it starts as default 0 and goes to 5. Okay, what if I do something like this? 2 semicolons and then 1. If I click run, all right, I get the default behavior. Because it's starting at 0 when there's nothing. It ends at whenever the string ends, when there's nothing, and then we're stepping over through it once. All right, but what if we do something like this? What if I do -1 here? This is a tricky one. What will happen? Let's find out. I get 7. In Python, the negative index means, hey, start at the end of the string. So that if I do -2, I get 6. If I do -3, I get 5 because I'm going backwards. And a neat trick that you can do here is if we do semicolon, semicolon, -1, and this is actually quite a common operation, so you just have to memorize this even though it looks weird. It means start, stop, there's no limit here, but I want to step over from the back. So what do you think will happen here? If I click run, do you see that? We get the reverse of the string. So this is a very useful notation if you want to, let's say, reverse an order. And if we want to, let's say, skip by 2, I click run, and you see that we're skipping by 2 now. Now, hopefully your head doesn't hurt with all this notation. You just have to get used to it. It's something quite unique to Python, but it's very, very useful. So up until now, we learned that strings can be accessed quite easily. And using the square brackets, we can access different parts of the string. And this idea of a start, a stop, and a step over is what we call slicing or string slicing, because we can slice the string however we like. But we also need to learn another important term that's going to come up again and again throughout this course. And as a matter of fact, it's an important concept that as you get more advanced into programming, you really need to understand. What is this concept? Well, it's this idea of immutability. It's an important term in programming. What does immutability mean? Well, strings in Python are immutable. That means they cannot be changed. What do I mean by that? Now that we've assigned selfish this value, this string, well, I can reassign it, right? I can say selfish is 100 now. And if I print selfish and I click run, that works. But if I instead do something like the first index of selfish is going to equal 8, and I click run, I get an error. I get a type error saying string object does not support item assignment. Why is that? Because strings are immutable. That is, I cannot change the value of this once it's created. I can't just immediately change it to 8, 1, 2, 3, 4, 5, 6, 7. No, it has to stay the same. The only way that I can remove this or change this is to completely reassign the value. So that in memory, Python removes all of this from our bookshelf of memory and instead just assigns 8 into the 0 bookshelf and removes everything else because we don't use it anymore. Now, this idea of immutability is something we'll explore more and more, especially when we start talking about lists. But for now, just remember that you can't reassign part of a string. Once created, it exists like that in that form. The only way we can change it is to create something new. We can do selfish plus 8, and we can create it that way. But now, this selfish is a whole new string. This no longer exists, and a whole new shelf space was created for us to use this whole new string. Again, if this doesn't make sense to you or why it's important just yet, don't worry. We'll get there. For now, though, I'll see you in the next video.